Hi class, so today we're going to be covering trig ratios for right triangles. This will be a bit of a review from what you would have learned in geometry with our trig values being sine, cosine, tangent, secant, cosecant, and cotangent. Now, what you've already have noticed, and you guys remember this before, you guys know that our sine values, cosine, tangent, secant, cosecant, and cotangent values are all made up of opposite values, adjacent values, and hypotenuse values. Each one of these indicated in the chart here. And we're going to be using these values today to come up with our trig ratios. So let's go ahead and dive right into a couple of practice problems. So for this first problem here, what I'm going to want us to do is I'm going to want us to solve for the trig ratio of sine theta. What is sine theta? How do we set up that ratio? Well, first things first is we want to make sure we label all of our sides. So we need to look at our reference point here, which is our theta value. Theta is our reference angle. This is the starting point here. And so to identify our opposite side, well, we're going to look at theta and we're going to look at that side that goes right across, and this is going to be our opposite side. The side that is right next to theta or sharing a leg with theta, this will be our adjacent side. The side that is opposite of the 90-degree angle, or also known as the longest side, and all this is our hypotenuse value. Okay? So we label our sides. We also want to make sure that we identify our values. Well, opposite here would be 3. Our adjacent side would be 4, and our hypotenuse side is, well, got a question mark here. We're going to go ahead and just scaffold back. How do we solve for a missing side of a triangle? Well, we got to implement the Pythagorean theorem. You guys know that's a squared plus b squared equals c squared. A and b being our legs, c being our hypotenuse. So let's go ahead and solve this out real quick. We'll say 4 squared plus 3 squared equals c squared. 4 squared is 16 plus 3 squared, which is 9, equals c squared. Well, 9 plus 16 is 25 equals c squared. Isolate our c, we take the square root of both sides, and we get that c equals 5. So just a little review of Pythagorean theorem. You guys did pretty well on that lesson, so I'm not too worried about this skill. Let's go ahead and come back to the trig ratios. So now that we know all of our sides, we've labeled everything, let's set up the ratio itself. So looking at sine, we want to set this up as opposite over hypotenuse. So we're going to say opposite over our hypotenuse. And we're going to take those values, our opposite value in this case being 3, over our hypotenuse value being 5. So we've already labeled, we set up our ratio, and to simplify, well, 3 over 5 doesn't simplify anymore. So we are allowed to say that sine theta is equal to 3 over 5. Simple identification. Cool. Let's go ahead and look at another problem here. Let's say I wanted to solve for the cosine of theta. So for cosine of theta, we're going to come over here to our table, and we're going to see that it's adjacent over hypotenuse. So before we set anything up, I want to label my sides. Again, we look at theta, and we're going to look at the opposite here, and this is going to be our opposite value of being 3. Our adjacent side would be 4, and our hypotenuse side is going to be 5. So when we set up our trig ratios here, we're going to see that it's going to be adjacent over hypotenuse. Now our adjacent value in this case is going to be 4 over our hypotenuse value, which is 5. So we've labeled our sides. We did our setup ratio. To simplify, well, 4 over 5 does not simplify any further. So we can say that cosine theta is equal to 4 over 5. Okay, we're good here. Let's do our next problem. Let's say we're asked to solve for tangent theta. Well, tangent theta, you'll see here, is opposite over adjacent. So let's go ahead and go through our steps. We know that our opposite side of theta is here. Our adjacent side is here, being 4, and our hypotenuse value would be 5. So dealing with tangent, we need to evaluate it as being opposite over adjacent. Cool. So our opposite value in this case, we've already identified it here at 3, will be divided by our adjacent value here at 4. We've labeled, we set up our ratio. To simplify, well, 3 over 4 does not simplify any further, so we're good there. So our trig ratio for tangent theta will be 3 over 4. And we're done. All right, let's do another one today. Let's do secant theta. Again, we go through our steps. We want to make sure that we identify our sides here. So here we've got our opposite, our adjacent, and our hypotenuse. So we label our sides. Now let's set up our ratio here. So secant theta is going to be indicated here at hypotenuse over adjacent. So we're going to take hypotenuse over adjacent. Our hypotenuse value for this question here is 5, divided by our adjacent value here, which is 4. We're done with our ratio. To get our simplified value here, well, 5 over 4 does not simplify, so we can say that secant theta is equal to 5 over 4. Done. Next problem. Let's go ahead and solve for cosecant theta. Well, with cosecant theta, we'll see that here we have a trig ratio of hypotenuse over opposites. So let's go ahead and label our sides. We've got our opposite, we have our adjacent, and we have our hypotenuse. So we've labeled our sides. To set up our ratio here, well, we need to identify that it's going to be hypotenuse over opposite. Our hypotenuse value here is going to be 5, divided by our opposite value of 3. Setup is done. To simplify here, well, 5 divided by 3 does not simplify any further. So we can say that the cosecant theta value is equal to 5 over 3. And our final problem for the day is we're going to be evaluating cotangent theta. Cotangent theta you'll see here with a ratio of adjacent over hypotenuse. So let's go ahead and label our sides first. So we have opposite, we'll have adjacent here, and we'll have our hypotenuse up here. So we want to make sure that we get our adjacent value as our numerator, divided by the opposite value in our denominator. So let's get those values. We're going to have adjacent here being 4 over our opposite value here at 3. So we've labeled, we set up our ratio to simplify. Well, 4 over 3 does not simplify any further. So it is safe to assume that our cotangent theta value is equal to 4 over 3. Well, class, I hope you enjoyed this quick review over trig ratios and how to identify our sides. So make sure that when we do our assignment today, you're going to go ahead and label your sides, set up your ratio, and simplify if needed. Just a reminder, I do have office hours every day, so if you have any questions, please go ahead and log on, and I'll be more than willing to help you guys through this. Hope you all have a great day, and best of luck on your assignment.